Okay, so we're on to now example number 2. I went ahead and wrote the problem out already. We are trying to find the area between sine and cosine between pi over 4 and 9 pi over 4. Okay, so what we can see here is this is our first bit. Now the one thing I want to point about this problem is that this problem is actually much easier than it looks, because it's very, very clear that this area and this area are the exact same thing. So what I could do is 2 times the integral from pi over 4 to 5 pi over 4, and then do this function here, which is the sine function minus cosine function, and leave it at that. If I didn't do this, the integral would look more like this. I'm going to go ahead and write it really small over here just so that you could see what would happen if you didn't notice that. So there's that first bit from pi over 4 to 5 pi over 4. Plus, we have to have a second integral from 5 pi over 4 to 9 pi over 4. And on this one, cosine is the higher function. Okay, so please recognize that these are the similar areas, especially if you're given it in a picture and it's clearly labeled as them being the same area. So don't do the more work than you have to. I am not going to work through this problem in full because I have confidence in your abilities to do the integral. So what I'm going to do is simply going to set it up for you and go ahead and give you the answer. And we're going to go ahead and use a calculator for that just to make sure you know how to do that. So 2 math 9. Sorry, not negative. Pi over 4 to 5 pi over 4, and then we said sine x minus cosine x dx. And that would be our answer. Let's see here. So we're going to go ahead and leave our answer. Now on the AP exam, what you need to make sure you're doing is your answer needs to be to the third decimal place, no matter what, because you're all going to be free response questions now. So there is that number right there. And that will be good enough for our answer for now. And just please remember that if this is a quiz or test, I do expect you to show all your work. I know y'all can find the integral of this. I know y'all can plug in those values. And I do actually, I will expect an exact answer for quizzes. So please keep that in mind. So you will have a square roots of 3 or 2 in your answer. Please keep that in mind. In this case, square root of 2. Okay, so we're going to do one more problem to make sure that we know what we're doing. Let's see here. By the way, this is, if you're going to do it out my hand, it's 4 square roots of 2. All right, so let's go ahead and go on to our last example. I'm going to need another page for this one. So I'm just going to go ahead and write this one out. And we're going to go ahead and go through it just to the setup portion to the integral. Because y'all, like I said, y'all know how to integrate already. And y'all have learned that in my previous lessons. So today we're just setting up the integral so you can go to the next step. Okay, so here are my two functions. F of x equals 3x squared minus x squared minus 10x. G of x equals negative x squared plus 2x. And we want to know what is the area between these two curves. Okay, so to show your work on this kind of problem, you need to find the intersection point. The way you do that without a calculator is you set them equal to each other. Because we want to know, where do they intersect? Where do they equal? And then what I'm going to do is I'm going to start solving for this equation. Move everything, in this case, to the left-hand side. So add x squared, subtract the 2x. Add x squared, subtract the 2x. And that's going to cancel that out, which is nice. And now this problem I can easily factor. I notice there's a 3x in both terms, so factor out what's in common. And then from here, what I can do is, so I have x equals 0 and 4. So then my integral is going to look like this, from 0 to 4. Now the only thing I still need to figure out is which one is higher between 0 and 4. Is it f of x or g of x? Well, the way I figure that out is by plugging a number in between these two. I'm going to choose the value 1 because it's an easy number to multiply by. So f of 1 and g of 1. Which one is bigger? Well, I plug in 1. I think I actually wrote down this problem wrong. It's okay. I'll just keep on going. Plug in 1. I get 1, so that's 2. 2 minus 10, which is negative 8. This is 1 squared, so that's negative 1 plus 2. So that's a positive 1. So clearly, g of x is greater. So I'll do negative x squared plus 2x minus 3x squared minus x squared minus 10x dx. Now, I know, actually, looking back at my example problem, I did write this down wrong initially, but so it's not the exact example from the book, but it still works out nicely. It's just how you set it up, and then from here you combine like terms and integrate and go from there. Okay. And that's essentially how you find the area between two curves. Okay. That's how you go set up process. And I know y'all have, like I said, the ability to integrate, so I'm not going to be going over that as much. So on the first few problems, I want y'all to go ahead and just evaluate, find the integral. That's it. So page 450, 5 through 10. You're not actually solving the integral. You're just setting it up. So this is just set up the integral. And then on numbers 15, we'll say 15 through 28 odds. And what I'm really going to be looking for here is that you set the problem up properly, you're showing your work, and then yes, you check your answer in a calculator. Use it as a tool, not as a crutch, or else you're not going to be able to do the quiz or test that's going to be coming up here in the future. And as always, if you have any questions, I do have my office hours every day. And if you can't make it in the morning, please email me. We can set something up in the afternoon for you.